Hello Year 4 students, welcome back to our e-learning class. Today we are going to discuss more about fractions. What is it about? It's about fractions and decimals. So our lesson objective for today is identifying equivalence of fractions and decimals. Before we continue, do you still remember a decimal number? A decimal number can be defined as a number where the whole number part and the fractional part is separated by a decimal point. The dot in a decimal number is called a decimal point. The digits following the decimal point show a value smaller than 1. In this discussion, we want to see the equivalence of fractions and decimals. How do we write 1/10 as a fraction? 1/10. How do we write 1/10 as a decimal? 0.1. Then how can we convert fractions to decimals? We can convert them by seeing the fraction bar and number line below. As you can see, 1/10 is equivalent to 1/10 and is equivalent to 0.1. 2/10 is equivalent to 2/10 and is equivalent to 0.2. The other example that we can see, 3/10 is equivalent to 3/10 and is equivalent to 0.3 and so forth until we get in this fraction 10/10 is equivalent to 10/10 and is equivalent to 1. Now let me tell you the easiest way to solve it. Can you see the fraction of 5/10 here? If you find any fraction that has 10 as the denominator or in base 10 form, it means you need to put one number after the dot, or one number in the fractions part. Of course, the number that you need to write is the numerator. So since we have number 5 as the numerator, in this example it means you need to put number 5 after the dot. But before the dot, you need to write 0 as well as the whole part. So we will get 0.5 as the decimal form. Let's try another example, 8/10. So how can we convert it? The fraction already is in the base 10 or has 10 as the denominator. So you just need to write the dot, then write 0 before the dot, then write number 8 after the dot. So you will get 0.8. But how about if we have 2 or more digits as the numerator? Example, 17/10 and 143/10. How can we convert them into decimal form? Just remember, since it is still in base 10 or has 10 as the denominator, it means we must always have one number after the dot. So 17/10 will be written as 1.7. See? We just have one number after the dot, only number 7. Then for 143/10, it will be equivalent to 14.3 in decimal form. Try solving these questions. Express these fractions as decimals. I will give you 30 seconds. 4/10, 257/10, and 26/10. Now let's solve it together. 4/10 is equivalent to 0.4. 257/10 is equivalent to 25.7. And 26/10 is equivalent to 2.6. Is this working use only to convert fractions in base 10? No. This working can be used for all the other multiples of 10 as the basis. So if we have 100 as the denominator or the base, it means we have 2 digits after the dot. If the fractions are in base 1000, it means we have 3 digits after the dot and so forth. But for our grade, we will just use base 10 and base 100 as the denominator. Let's try to convert the fraction that has 100 as the denominator. Example, 4 over 100. First, we will use the fraction bar below. 4 over 100 is equivalent to 0.04. 6 over 100 is equivalent to 0.06 and so forth. Now let's try to use our easiest way to express 4 over 100 as decimal. Since the denominator will be 100, it means we will have 2 digits after the dot. But since 4 is only a digit number, we need to put one more 0 before writing number 4. So we will get 0 and 4 as the digits after the dot. The final answer will be 4 over 100 is equivalent to 0.04. But what if we want to convert 14 over 100 and 143 over 100 into decimal form? For 14 over 100, since the numerator 14 already consists of 2 digits, we will directly write 14 as the digits after the dot. Then, we write 0 as the number before the dot, so the final answer will be 0.14. It will be the same for 143 over 100. Since we just need 2 digits after the dot, it means we will just write digit 4 and 3 as the number after the dot or the number in fractions part. Then number 1 we put it before the dot as the whole part. But how are we going to convert the fractions that aren't in base 10, 100, or multiples of 10? Example, 4 over 5 or 3 over 25. In solving this problem, we need to change the denominator into other multiples of 10, or we need to divide the numerator with the denominator. For now, we will solve it by changing the denominator into 10, 100 or other multiples of 10. The trick is, change it into the closest base 10. Example, 4 over 5. Now see the denominator, number 5. Number 5 is closest to 10 rather than 100. It means just change it into 10. How? Like finding the equivalent fractions. Do you still remember how? Fraction 4 over 5. Let's change the denominator into 10. 5 times what number is 10? It turns out that 5 times 2 is 10. So since we multiply the denominator by 2, we must also multiply the numerator by 2. 4 times 2 is 8. So 4 over 5 is the same as 8 over 10. Now it will be easy to find an equivalent decimal fractions for 8 over 10. Just use the concept above that I discussed in the beginning of the video. The answer will be 0.8. Now, try to solve 3 over 25. Since it will be impossible to change the denominator 25 into 10, so we will change it into 100. How? 25 times what number is 100? It turns out that 25 times 4 is 100. So since we multiplied the denominator by 4, we must also multiply the numerator by 4. 3 times 4 is 12. So 3 over 25 is the same as 12 over 100. Then 12 over 100 is equivalent to 0.12. Now let's try to solve one more example. Find the equivalent decimal of 3/4. I will give you 30 seconds. Let's solve it together. What is the possible and closest base 10 for number 4? It is possible for us to change the denominator into 100. 4 times what number is 100? It turns out that 4 times 25 is 100. So since we multiplied the denominator by 25, we must also multiply the numerator by 25. 3 times 25 is 75. So 3/4 is the same as 75/100. Then 75/100 is equivalent to 0.75. I hope this video will help you understand how to learn the relation between fractions and decimals. Just like the previous video, try to solve the questions on a piece of paper or your notebook. Take a picture of it, then submit it to me before you click Turn In. Kindly use the working for the needed questions. Thank you and see you in the next video.